Welcome everyone. We have this nice log equation and we have to find the value of x. So let's start. So we have log base 2x and log base 3x and the sum is equal to 1. So we can solve this equation by changing the base. So first we need to understand what is changing the base of our log equation. So I am writing it down here. Suppose you have log base a and b of b and you want to change this base to some other quantity c, then you can change it by transforming the equation like this: log base c of b by log base c of a. So this is the way you can change the base of the log of any equation. So remember this formula because we are going to use it to change the base of the log. So because here the base is 2, here the base is 3, we can do two things. We can either change the base, we can either use this also: log base 2 of x is equal to log base x of 2 reciprocal. What do I mean? If there is a log of base a of b, then this is equal to 1 upon log base of a, and if we change them, then both the logs will have the base x, but I am using this one. So let's see how to we can solve in both ways. You tried the right hand side way and I'll try the left hand side way. So we have log base 2 of x plus we are going to change the log base 3 to log base 2 again. So how will you change log base 2? You can write it down as log base 2 of x by log base 2 of 3, and it is equal to 1. So if you take LCM, what you will have? You will have log base 2 x multiplied by log base 2 3 plus log base 2 x whole upon log base 2 3 is equal to 1. Now shift this quantity on that side. So you will and take common log base 2 x on in the numerator in both the sides. So you will have log base 2 x common, and then you have log base 2 3 plus 1, and here you will have log base 2 3 and whole multiplied by 1, which is same. Now I am going to use one more thing, which is log any base of same number is 1. So we can replace 1 by this quantity. We can replace 1 by this quantity here. So I am going to replace this 1 now. So I can write log base 2x log base 2 3 plus log base 2 2 is equal to log base 2 3, or log base 2x, and now I am going to use addition property of the log, which says that log base 2 3 into 2 is equal to log base 2 3. So now you have log base 2x, and this whole quantity I am shifting it on the denominator of the other side. So you will get log base 2x is equal to log base 2 3 over log base 2, and this thing is 6. Okay. So now we have reached till here. So what to do now? Again I am going to use the property of changing the base here. We know that log base a of b upon log base a of c is equal to log base c of b. Okay, this property I have already discussed. Now I am going to use it in the reverse way. So here you have log base 2 3, log base 2 6 in the denominator. So you can write log is equal to log base 6 of 3. Actually this is your b, this is your c, and this is your a. So just compare this equation by this equation and you will see what I have done. So now you get log base 2 of x is equal to log base 6 of 3. Again you have some problem because here the base is 2, here the base is 3. So you cannot remove the log. So what you can do is, you know that log base a of some quantity n is equal to suppose b, then b is actually the exponent in the log equation, or you can call it power. A is actually the base, and what is n? N is the base to the power is equal to n. This is the alternate equation of the base equation. Okay, so we have this type of equation here. The base is 2, n is x, and power or exponent is this whole thing, power. So you can change base to the power, use this equation now. Base to the power means 2 to the power log 6 of 3, and this will be equal to x. So x is equal to 2 to the power log 6 of 3. This is your final answer of the question. Thanks for watching the video. I hope you have understood it. If you have a better way of solving it or any other correction you want to make, let me know in the comment box. If you have any other question you want me to solve, give it to me.